my last video I showed you all how to use S Stats Plus and run an analysis of variance, the ANOVA test, with 3 sets of data to analyze differences in variance to test the null hypothesis of there is no change or difference in variance between the 3 groups. So our ANOVA test resulted in an F value of 3.98 and compared to a F critical value of 3.10 and a P value of 0.02, which means that we are statistically significant, and we have determined that we can reject the null hypothesis. But what we don't know is which one of the 3 sets of data actually has a variance that is out of the normal range, that's statistically out of the normal range based on a treatment. In order for us to do this, we're going to use a post hoc test called Tukey, and to find which set of data actually has the abnormal, statistically abnormal variance. So what I've already done is I've exported this data to Excel here, and my end result looks like this. Okay, but I'm going to start us off here. In order for me to run this post hoc test, what I need is I need to find I need the sums of my data sets, and I need the means of my data sets. I have already copied over my ANOVA statistics here, and I've plugged in a number of values that I will have to find. So the first important value that I'll need to find is my Q upper critical value, and I'll need a studentized Q table to find this. My Q value. My Q value is equal to my Q value. To find my Q value, I'll need the numerator for my degrees of freedom and my denominators for my degrees of freedom. The numerator for my degree of freedom is actually the number of groups I have. So in this case, I have 3 groups, 1, 2, 3. And my denominator degree of freedom is the total observations minus my number of groups. In this case, my total number of observations is, I'll just quickly do the math, my total number of observation is 29 times 3, so that's 87, and if I subtract my number of groups, I get 84. So my denominator df is that, and my numerator degree of freedom is 3. With that information, I'm going to use my critical values of studentized range distribution table to find my Q critical value. My numerator degree of freedom is here, so I'm going to find the column that's associated to 3, and I'm going to go down to 84, which is my denominator degree of freedom, and find the associated Q critical value, and that is 3.374. With that information, I'm going to plug it in to my 3.374. I'm going to plug it into my table. I'll walk you through all of these formulas as I go. The factor level is the number of treatments or the number of groups. So I've actually had 3 groups. Again, action, the groups, the same set of people that watched an action movie, then they watched an animation movie, and then they watched a comedy. So I have 3 groups, so I'll plug that in there. My N is the number of observations less my number of treatments. So I'm going to type that in. I know that I have that down there already, so I know that that's 84. My number of observations. Actually, let's double check that. Yep, my number of observations is 84. Next, I need what is called the S squared pooled value. And this is actually given to me in my ANOVA results. And that is the MS within group value. So I'm going to grab that right here. So this is my MS within groups. And that's actually the sum of my means squared. Now we're going to move on to the next, which is N. And N is the number of observations in a particular group. And so the maximum number of the maximum number of observation in a particular group is 29. So I'm going to find that here. Okay. Now that I've done that, what I've already done here in this comparison group is figure out the number of possible combinations that I could potentially have. So what I want to do is I want to compare group A to B. I want to compare group A to C. And then I'm going to compare group B to C. I then need to know what my absolute difference is, absolute value of the difference is between A and B. So I have my formula there. My absolute value between A and C. So I have my formula there. And my absolute value between B and C. And just to be clear, this is the difference between the means of each group, between two groups, the difference of the means between two groups, the absolute value. And to find absolute value, you'll type in the formula equal ABS, and then you'll get the absolute value. Now, I'm going to type in my special function for my critical value, for which I will compare my absolute difference to figure out if there is a significant difference between the groups. And once I do that for all of my comparisons, I'll be able to determine which group is different, statistically different from the rest, to figure out which group has the statistically significant change in variance, abnormal change in variance. So let's go ahead and type in this special formula. So for the critical value, I'm going to type in, it's going to equal the Q upper critical times my square root, and the square root formula is SQRT, the square root of my S squared pooled value divided by N period, which is the number of observations in a particular group when my observations are equal. And in this case, my number of observations are all equal for all of my groups, so I can actually run this test. Okay, I'm going to go ahead and lock all of these cells because I'm going to pull them down for my three comparisons. Okay, and then I have a formula here that tells me if my absolute value is greater than my critical range value, input that there's a difference, that there's a significant difference between the those two groups. So I've done that for A to B. I see that there is a difference. Group A to C, there is no difference. In group B to C, there's also no difference. So I see that there is a difference between A and B. So I can determine that A is my group that has a significant difference in variance, and so I can determine that out of the ones that I compared, so I can determine that that is the group within my ANOVA test that has that statistically significant difference in variance. This is how you conduct an ANOVA test and a post hoc test to find which group in your ANOVA test has a statistically significant difference in variance. Thank you.